Okay, this is the 2017 BC Calculus exam. It is the Form B version, and it's number 5 that I was going to kind of walk through today. So it says, consider the differential equation dy dx equals that 3x plus 2y plus 1. And part A says, find the second derivative in terms of x and y. So we'll go ahead and get started there. I can actually fit it right up there. So just know that the second derivative, okay, so I take the derivative of this to get the second derivative. Now the derivative over here, I'm taking it with respect to x, so anytime you take the derivative of something that's not an x, you're going to have to tack on a dy dx. So the derivative of 3x is just 3, that part's easy. The derivative of 2y is just 2, but you took the derivative of something that's not an x, so you need to tack on dy dx. And the derivative of 1 is just 0. Now, that's good, but there's this little caveat here. It says, in terms of x and y. Meaning they don't want dy dx in my answer, so I need to get rid of it. Well, how do you get rid of it? Well, it tells me right here that dy dx equals this, so I'm going to take this and put it in right there. So this equals 3 plus 2 parentheses 3x plus 2y plus 1. And I would safe stop it there. You could, if you wanted, distribute, and then you could combine like terms. And I think if you did that, you ended up with something like 6x plus 4y plus 5. But I would recommend a safe stop there. All right, now part B is pretty tricky. I'm actually going to skip part B and go to part C and D first, and then I will do part B at the end of the video for those of you that would like to know how to do part B. Okay, so I'm just going to do part C next, okay? And what I like about part C is that it's Euler's method. So with Euler's method, I kind of have a plan, and I'm going to go ahead and kind of carry out my plan. So it tells me that my step size is a half. Okay, so it tells me that my step size was 1/2. And whenever I do Euler's method, I kind of make my table here. So I have x's and y's, and I have my step 0, step 1, and step 2. Okay. So my initial condition that they gave me in part C was that f of 0 equals -2. So my initial condition goes here. I go 0, -2. And remember, your x row is kind of easy. All you do to get the x row is you do 0 plus your step size. And so we get a half there. And then again, you're using the previous entry. So 1/2 plus 1/2 equals 1. And you want to make sure that this 1 matches what you're trying to get. So it says try to approximate f of 1. So that last entry in the x row has to match that. So this is a 1 and that's f of 1, so that's good news. So that's kind of the first step. And then I'm going to go ahead and to get this bottom row filled in, you're going to use that previous entry. So it's -2 plus 1/2 times something. And that's kind of, you know, the part, that's something. How do I get that something? So to get that something, you have to go back to the previous point. So I always just kind of do some scratch work off to the side, and I say at 0, -2, that was the initial condition, you need to evaluate that original derivative. So at 0, -2, dy dx equals, well, all I need to do is take this 0, plug it in for x, take -2, plug it in for y. So you get 3 times 0 plus 2 times -2 plus a 1. So let's see, with some quick math there, 0 minus 4 plus 1 gives me a -3. And this -3 is actually what's going to go in here. So you have a -3 right there. And via some math here, what is that? -3/2 minus 2 more. So -3/2 minus 2 more gives you -7/2. Okay. And again, remember, Euler's method is always dependent on the previous. So now I take this -7/2, and I have it up here, so it's -7/2, plus the step size times something. How do you get that something? You go to your previous point. So my previous point this time was 1/2 -7/2, and I'm going to evaluate the derivative there. Okay, so now when I plug in that, I'm going to get 3 times 1/2 plus 2 times -7/2 plus 1. And you can go ahead and get a common denominator there, so you end up with something like -14/4 minus 9/4 right? And then I think that's going to give me a negative 9 halves. Okay, so that's negative 9 halves. So that's just kind of cleaning that up. Now you take that negative 9 halves and you're going to put it back up here. Okay. So let's see. Yeah, because over here, let me just make sure. Yeah, that's 3 halves minus 14 over 4 plus 2 over 2. Yeah, okay. So now I take that, put it over here, and now it's just kind of cleaning up that arithmetic. So be careful here. This is going to turn into fourths, so you need to turn that into fourths. So that's negative 14 fourths minus 9 over 4. And so that gives me negative 23 over 4. And you can kind of write your conclusion there. So my conclusion is that f of 1 is approximately negative 23 over 4. And you would get full credit, for that answer there. Okay, so that was part C. And now we can take a look at part D. Because again, part A, C, and D I thought were very, very doable to get your points. And I always tell my students, you know, if you're averaging 6 points per free response problem, you're doing really good. So we've got this. All right, let y equals g of x be another solution to the diffie q with the initial condition, g of 0 equals k. So that's interesting. We got a variable now. And where k is a constant, using Euler's method, starting at 0, step size of 1. And it tells me the approximation. Where here I had to get that information, like that was what I was finding, they gave it to me here. How nice of them. Now I have to find the value of k. So my method here is still going to be the same. I'm still going to have my x column and my y column. Only this time, when I do it, I only need 2 step sizes. So I'm going to have, my initial condition and then just 1 step. Sorry, not 2. And my initial condition was at x equals 0. The output was k, so we've got that. And now I have, it says with a step size of 1, obviously 0 plus 1 is 1 there. Again, I always make sure that this one matches the one I was trying to get, so that's good there. And now I have to figure this out. Well, it's going to be k plus, my step size was 1, parentheses, what you get when you plug in the previous points. So I always do my little scratch work. So at 0k, when I plug into the derivative, okay, so I would get, dy dx, what does that equal? It's going to be 3 times 0 plus 2 times k plus 1. All right, well, isn't that just 2k plus 1? I guess that's what I got. So I'm going to take that and plug it in here. So that 2k plus 1 goes there. And now I can clean that up. Obviously, that's just k plus 2k plus 1. And I can combine like terms there, and I get 3k plus 1. The question, though, says what was k if I was given the answer. So I know, just like here, this was the answer to f of 1 was approximately that. They're telling me that this has to equal 0. It told me right there. So then I can just say that 3k plus 1 equals 0, and then it becomes just an algebra problem. Subtract 1 and divide by 3, so I get k is negative 1/3. Okay, so here, if you were able to do all 3 of those, which I think are pretty good, again, you've gotten your, your 5 or 6 points here. I didn't check the scoring guide exactly. I think that those are pretty doable. So for those of you that are interested in Part B, I would recommend you kind of flip your paper over because it takes a little bit of work. And I'll just kind of read through it real quick. Okay, so our goal here is to find the constants m, b, and r that satisfy that y equals is the solution to the differential equation. So I kind of started, let me walk you through it on the back here. Okay, so I started off by writing down that y equals equation. And I want to figure out, the solution to the differential equation. So I take the derivative, okay? So the derivative of y with respect to x, well, the derivative of this, remember, m is a constant, so my variable is x. So the derivative there is just an m. This is a constant. It told me that. So the derivative of a constant is just 0. And the derivative of e to the junk is e to the junk times the derivative of the junk. So the derivative of that is just an r. Okay. So then I just rewrote it again without the 0. So I've got this. So I've got this equation, and I need something to set it equal to. Well, the good news is that I know what dy dx is. They gave that to me in the problem. So I go back to, you could flip to the front and see that dy dx was this problem. So now I have something to set those equal to. Okay? Let me scooch that up. Okay, so I think most students are okay to this point. And now our goal here is to try to kind of make these things match. I want this to look like this. And you're like, well, it doesn't. Well, one of the things that's a problem is this y value. So I need to get rid of this y because the constants, kind of the things I was concerned about from the problem were that m, the x, and the b. So I definitely need to get rid of this y. So what I did to get rid of this y is I took the y that they gave me. They told me that y equals this. And I like this because now this has that m in the b that I wanted to relate the other equation to, so I substituted that in. So all I did is I took this y and I replaced it with that given equation. So you just pop that in there, okay? And then I distributed the 2. Sorry, I got a little squished. Okay, so then you're to this point and you're like, wow, this equation is getting messier. Okay, well, my goal here is to kind of get it all in terms. So see, there's x's here. So I took out a GCF of x and I rewrote it. Now, here's kind of the key part. Notice over here, there is no x term, okay? There's not something where it's whatever x. So the only way that that's going to happen is if the coefficient on x was 0, right? So here, there's no x term. I know that there's an x in there, but I'm talking about the actual term, okay? So there's no x term, which means, okay, that the coefficient on x equals 0. Well, what does that mean for this part? That kind of gives me something. It tells me that the coefficient on x, aka this part right here, that has to be 0. How do I know that? Because there is no x term on this side, so that's what it has to be. So once I do that, I can solve for m. So that means that m equals -3/2. Okay, using that same kind of logic of the matching. So there was no x term. Now over here, there is this e to the junk stuff, right? And I also have that e stuff over here. So that means that this piece has to equal that part over there. So r e to the rx. Okay, and what does that tell me? Well, this part is that. So what does r equal? That must mean that r equals 2. So you've got those two, and now we need to get the last piece. Okay, so for that last piece, I have got those two pieces that I have not used yet, okay? So the two things that I haven't used up here, right? So I haven't used this 2b, and I haven't used the +1. So what does that tell me? Well, what's the only thing that's left? It's the m. So now I also know that 2b plus 1 equals m. And you're like, well, that's terrible because that's, two variables again. But now I know what m is. So now I just substitute that m in there. So that's -3/2. Subtract 1 from both sides. So that's -5/2. Divide both sides by 2. So I got -5/4. So now it asked me to solve for r, m, and b. That's exactly what I've done. I do think that that was a pretty challenging section of this. But again, if you're averaging 6 per free response, you're doing good. I thought that the points for Part B were a little challenging in this one, but I thought that the other portions were really reasonable. So, and I can kind of scroll that back down so you can see a little more. Okay, have a great day.